Let's say now that we want to choose 3 people out of 20 for 3 different prizes. In how many ways can we choose those 3 people out of 20? Well, first we've got to choose the first person. Let's say there are 20 choices. Well, there will be 20 choices for the first person because nobody's been chosen. Now, we have to choose the second person. We've got to choose somebody different implicitly here. And since we've already chosen one person, there are only 19 left, so there are only 19 choices for number 2. And then now that we've chosen 2 people, there's only 18 choices left for number 3. In how many ways can we make 20 choices followed by 19 followed by 8, or a choice of 20 followed by a choice from 19 followed by a choice from 18? Well, there are 20 choices for the first person. For each of those choices, there are 19 choices left for the second. 20 times 19 is 380. Then we multiply that by 18, because for each of those 380 there are 18 choices, and we get something around 7,000 possible choices. Okay, that's 20 times 19 times 18. We call this P of 23. P of 20, comma 3. P stands for permutation. Now, permutation means that when we choose these people, the order in which we choose them matters. So we choose 3 people in order in P of 23, 20, comma 3 ways, where P of 20, comma 3 is 20 times 19 times 18. The first number is the 20, and then we choose 3 numbers, or we use 3 numbers, 20, 19, and 18. That's where the 3 comes in, and we'll see more about that in a minute. But you should see where those numbers come from even right now. Let's do a slightly more complicated problem. Let's say we've got 10 men and 10 women in a group, and we want to choose 3 people for prizes, but we want to be really sure that at least one of those people is a woman. Okay? So the simplest way to analyze that, to see how many different ways there are to choose these 3 people, is to ask, well, how many ways are there to choose 3 men out of this group? Okay? There are 10 men, so that there are P of 10, 3 ways to choose 3 men in order. Okay? And I should have specified here we're getting different prizes, so the order in which we choose these people determines the prize each one gets, so the order does matter here. So we have this many ways of choosing 3 out of the 10 men, which is 10 times 9 times 8. Now, out of the 20 people, there are P of 23 ways to choose 3, which is the 20 times 19 times 18 that we saw before. So that in order to choose the 3 people with at least one woman, we have to choose 3 people, but we can't choose 3 men. So we're going to subtract the number of choices of 3 people out of 20. From the number of choices of 3 people out of 20, we're going to subtract the number of ways that we can choose the 3 men. And then this many of the possibilities will have at least one woman. We can look at a means of calculating P of 20, comma 3, which we know is equal to 20 times 19 times 18, and hopefully we understand that reasoning. In terms of this factorial notation, now remember, you've read in your text, 20 factorial means 20 times 19 times 18 and so forth. So actually we can write 20 times 19 times 18 as 20 factorial divided by 17 factorial, as we see. If we write 20, 19, 18, 17 times 16 all the way down to 1, and divide that by 17 times 16 times 15 all the way down to 1, what's going to happen? Well, 17 will divide 17 and give us 1, which isn't going to affect our result. 16 will divide 16. 15 will divide the 15 that is in these dots here. In other words, everything from 17 down to 1 will divide one of the numbers from 17 down to 1 here, and we just end up with 20 times 19 times 18. which is, as I've said, 20 factorial over 17 factorial. Now, in terms of the 20 and the 3, we'd write that as 20 factorial over 20 minus 3 factorial. 17 being 20 minus 3. Now, this doesn't mean 20 factorial minus 3 factorial. There's no distributive property for factorials. What this shows us is how we can come up with a formula for P of nr, where n is the number of people or the number of objects from which you're choosing, and r is the number of objects being chosen. And that's going to be, by analogy with this, n factorial over n minus r factorial. Because the n minus r factorial will consist of the numbers from n minus r down to 1, and will cancel the numbers from n minus r down to 1 in the n factorial, leaving us just the numbers that we need to make the permutation. Okay, in the next clip we're going to look at how many ways there are to choose a committee of 3 people from 20 people. When you choose a committee, the order doesn't matter.